All right, everyone. Welcome to the third and penultimate CS module lecture. So before we get on to that, a few really quick announcements. The CS Module 3 assignment is going to be available soon, i.e. within the half hour. We're working on a few quick bugs, so yeah. The assignment is going to be due on Sunday, as always, midnight. And feel free to reach out to us if you have any questions, if you're having any trouble with the modules. Ideally, you shouldn't be spending more than like 2 hours on each module. So definitely reach out to us if you're spending more time on that. I believe that everyone has turned in their mid-semester assignments. I was able to take a very good look, but I think from what I've seen, they've been very impressive. And so I'm looking forward to seeing what sort of projects you guys come up with. And then hopefully within the next week, Exec will also have some comments on the assignment on B courses for you guys. So with that, I'll give the floor to Dina, who'll be running the lecture today.
Okay, hello everyone. Sorry that there are two of me. My video on my laptop's not working. If at any point you need to use the one that doesn't have video, because that's the one I'll actually see. So. All right, let's get started. All right, so let's start by talking about, can everybody hear me? I'm not sure if I disabled the audio correctly.
Yeah, we hear you loud and clear.
Perfect, thanks, sorry. All right, so let's talk about imports. Local imports are quite simple. That just means when you're importing some previously existing code from the directory you're already working with. So let's do a quick example. I'm going to import a file in my directory called nom. Now, this file contains a couple of functions that generate names. They're super simple. They just return lists of potential names. Look at that. If I want to access one of those after I've already imported nom, I can say nom.nom bishat. So this is a function in that file. I'm going to run that. Oh, whoops, I'm sorry. So sorry, let me fix something. I did not prepare this correctly. Sorry about that, I wasn't in the right directory. I'll just quickly fix that. If anyone wants to say something fun when my computer's being slow, go ahead.
Well, I'll take the opportunity to say what I just said in the chat, which is if you've got questions at any time, you should feel free to unmute yourself and say it out loud. And also, I'll be looking at chat and the participants raise hand function if you want. And I think Dina will also be looking at chat, but of course she'll be on the Jupyter Notebook, so she might see it a little bit later.
Again, very sorry for the wait. I actually have quite slow internet.
So Dina, do you want to talk a bit about what you're doing and the importance of being in the right directory for these local imports?
Yes. Sorry, also we're good now. Okay, so as I mentioned, I have a file called num in my directory. Now, the reason that is not in English will be apparent in a moment. I just wanted to show you an example about how we can rename these things for our convenience in the future. So let's look at one of these functions inside this file. This is just going to return a simple list. Yikes! Oh my gosh. What have I done? Guys, I'm so sorry. Again, while I'm figuring out why I'm being ridiculous, if anyone wants to add something, absolutely go ahead.
So while Dina figures that out, I'll talk a little bit about the purpose of imports and what they are and why we care. So essentially, we've done a lot of coding in Jupyter Notebooks already, where we just define things and we move on to the next cell and we define a new thing based on that and so on like that. But you can imagine that doesn't like scale very well. You've probably seen when you were doing your CS modules 1 and 2 that a few times you had to like restart the kernel, rerun all the cells above, and that's not a really good way of doing like any sort of complicated coding. So what we want to do is start writing code in their own text files, and you're going to get some experience with that in the last CS module in CS4. But right now, what we care about is if someone has written code in a text file with an extension .py, then how do we get that into our Jupyter Notebook and how do we work with it in the same way we used to? You actually do use imports a bit just in the cells that we don't tell you, that we tell you not to care about in CS modules 1 and 2. You know, the thing at the top with like import math, import source defender, that's this kind of thing. And now I'll hand it back over to Dina to show you how that works.
So I'm sorry about that. Also, what I did wrong is I just didn't check to make sure I was in the right directory. Sorry, it's just kind of those, like, as soon as you're giving a lecture, you suddenly forget everything you know. Well, anyway, back to the content. So I imported a function from a previously existing file, and all this function does is it returns a list of potential cat names. This means names of cats in French. So this is what we would call a local import. I'm importing something from something in my directory, and I'm taking advantage of it. So if we wanted to change the name, very easy to do. So I would go from the file in question, import, as I've already done. We actually don't really need to do that twice. I'm just showing you how you would do it if you wanted to change it, because there are many reasons we may want to use a different name for a function. Most of the time it would just be for brevity, but it can also make something more appropriate in our context. Like, for example, I don't want it to be in French, I want it to be in English. So I'm going to rename this names for cats, and then I'm going to run it. What?
Can anyone spot this?
Because apparently I'm too nervous to remember anything. So if someone else wants to chime in, absolutely welcome.
Badma's got it in the chat. It should be nom de chat with an S on the end.
Thank you.
Please don't judge my French pronunciation. I haven't had French since middle school.
I spoke French fluently as a child. I forgot most of it, but still like to pretend I know what I'm doing, apparently. All right, so now let's just make sure that returns what we want it to do. It does. Excellent. All right, now an example of external imports. So that's when we want to import from somewhere other than our actual directory. So in that case, we would use pip. Pip is basically a path from Python to a bunch of packages we'd like to take advantage of. Now, some interesting packages that are worth knowing are pandas and NumPy. So what pandas is it's a software library. And if you've ever worked with Excel, you're familiar with data that comes in, columns and rows. The pandas is very helpful for manipulating that and sorting it, creating visual representations. I've heard people say when you use pandas, you'll never want to use Excel again, and that's a fair claim. And then NumPy is for higher level mathematical functions. So if you're using Jupyter Notebooks, which you guys I think are going to be coding in the terminal, but if you're using Jupyter Notebooks, you would say !pip.install pandas. And it's already installed, so that's not going to really do much. It's just going to say that. But I'm going to import and change the name in a minute. And this is the syntax. If you forget it, don't worry about it. It's in your module. Don't stress. Just want to show you that that can be done. And after that, let's change the name as we import it. Let's import pandas as PD for brevity. All right, now let's move on to a new topic now that well, actually, are there any questions at all regarding imports? Sorry for my little mishaps earlier, but any questions? Okay, cool. Moving on.
I've got one if no one else does. Once I've imported pandas from this external source, how do I work with it?
Okay. That's not the simplest. Well, okay, that is the simplest question. Can we do an example of that at the end, though?
Okay.
All right, so moving on to lists and list comprehension. Earlier, as you saw, we imported this function that generates a list. So if, for example, I want to rename it again. I want to make it something simpler because I picked such a long name. So let's say, let's say I just want to bring up the list again. If I run this, what do you think is going to happen? Like if I push run right now. Anybody? Is it going to give me the list of names? Well, let's see. No, it didn't give me the list of names. It actually was like, hey, this is a function, and functions take in a variable. So even though this one doesn't do anything with variables, we do have to recognize the fact that functions take in variables and include our empty parentheses. And then we can run it, and then we will obtain, if I can type, our list. Now, what if I don't want to have to deal with my parentheses every time? Let's just create a variable and assign that variable to this list. So let's call it cat names. Does anyone have any questions on the syntax here? So we're calling this is a variable. So we're not going to, of course, need to include any empty parentheses. But this was a function that returned a list. So we're now assigning this list up here, this name, cat names. That clear? Okay, cool. Now we can double check that everything's fine by running it and making sure we have that. Okay, so you guys have already worked with lists a little bit, if I recall correctly. So what will I get if I run now?
That should return stripes.
Excellent. Just wanted to remind you guys about how the first one is indexed at 0, not 1. It can be easy at the beginning to look past that. Now, what if I did this? What would that give?
Index out of bound arrow.
Error, yes, because there is no 4. There are 4 elements in the way we would count them, but in the way Python interprets it, there are 0, 1, 2, 3 elements. So there is no element 4. All right, I'm going to go ahead and bring in another list here that we can work with. I'm going to do exactly what I did before. So if there were any questions about that, feel free. There's someone in the waiting room. I'm going to carefully check my spelling so I don't do what I just did. All right, now let's take a look at this list. Let's simplify it again, just like we did before, so we don't have to be running the function, so we just have that list now. And there it is. All right, so something we can do with lists is we can add them together and they come out very cleanly. Let's say we want to combine these. We're going to combine cat names and fish names. Easy. Now, what do you think would happen if, so that's adding lists. We can also multiply lists. So if I do something like this, double predict this will return? Any ideas?
That should make one list where you have the entries of cat names twice. So if we have Fluffy, Squirrel, and Stripes, we should get it twice.
Exactly. It repeats it. So just to be clear though, this wasn't really defined in the answer. It's not fluffy, it's the whole thing, then the whole thing again, because we're saying that list, adding another list. That's what we mean by multiplying a list. Now, say for example, we had a list of numbers and we want to alter the elements in the list through multiplication. That's a bit different. In that case, we're going to look at each element individually. So let's define this list of just a couple numbers. Now, let's say each element times 2 for x, which you can use anything for x. X is just defining an element of a previous list in the listia described. Now remember, we would want brackets around to define that this is a list. We're not just making a statement here. And we've doubled every element. So that's pretty simple. Any questions there about how to modify elements of a list? We'll go over a little bit more about that. All right, now let's look at something else we can do. We can also do something called appending a list, which would be adding an element to the end. There are actually multiple ways to accomplish that, but let's review this method. Catnames.append. Anyone want to give me a good name? Please.
Garfield.
Perfect. Is that how you spell Garfield? Well, it is now. Now let's return cat names. Now, what if I decide I don't like that name anymore? Wasn't a good suggestion. Catnames.remove. Nice and easy. Going to take away, we're going to specify which one we want to remove. We don't necessarily have to remove Garfield, but let's go ahead and do that. You don't have to remove the last name though. The last one though, you specify which element you want removed in your print. Now it's gone. Okay, so now what if we want to identify where an element is? Like say, for example, we have an extremely long list and maybe our list includes rankings. So it's often going to be important to know the position of something. So I'm going to just find a new variable and I'm going to call it position of. I want to find out where that name was in this list of cats. I'm going to go list name dot index, and then I'm going to specify the element that I want to find. And then we want to view it, so nice and easy. All right, let's look at another example. Let's use extend. Cat names dot extend by our previous list that we also used, fish names, names for fish. And now let's return cat names and see what it looks like. Any ideas? This is quite a simple one. What are you guys expecting? Based on what extend means in English.
I think you've got a typo there. In extend.
I do.
Yeah.
Thanks. Well, okay, it's going to extend the list by the input we entered. Lovely. Now let's just go ahead and set that back to what it was before to use it again simply. I'm saying cat names equals names for cats, the result of that function. I'm just setting it back so it no longer has the fish names. There are other ways to do that though. Don't feel like that's the only way. Now, what do you think here? Let's really take note of the fact that we didn't put a string in there, we put a list. So what if, for example, I said cat names dot extend, and for the input, I put a string. What do you guys think the result is going to be here? Is it going to be the same or is it going to be different? Any guesses? I will call on somebody if nobody answers.
So this is just a wild guess, but I imagine cat names is just going to have apples put at the end of it.
That would be a completely fair assumption, but what actually happens is kind of a mess. So we want to see it so we know never to do it. It's going to put every individual element of this string in as an element, and that's kind of, not fun. So keep that in mind. That's a very simple mistake to make in the future that would make things a little bit more complicated. So just want to show you what that would look like. Okay. So now we've set it back to our original list of a couple names. Now there's also a way to check for an element in a list, which again comes in handy very often. And this is how. Your string, remember to include your quotations, and also this has probably already been mentioned, but just want to remind you, you can use double quotes or single quotes. They mean the same thing and you can actually use them interchangeably. I would stick to one just because that's cleaner, but you can, your code will still run. So let's see if cats is in cat names. Turns out it is. And is Garfield? So helpful. We can check to see if things are in our list. All right, now say I want to do something else. I want to modify each element in my list again in a different way than from before. Say I want to be dramatic and I want to add an exclamation point to all of my strings in my list. Does anyone have an idea of what to do? Does anyone want to tell me what to type? And if you're wrong, that's okay, but I want to get a sense of where we're at. Last chance to volunteer. Okay.
I'm thinking like if you make a for loop, you could say like for like each element in your list and then like append an exclamation point to the existing string at sort of like redefine it using a for loop.
Do it like that. It will be also again very nice and clean if you're using for. It doesn't have, you don't really have to go through each one. Sorry, I didn't explain that well. Python will do it for you. C for C. basically I'm saying C stands in this case for any individual element in the list that I'm working with. And then what I want to add an exclamation point, which would be in quotes. For C, again, just C represents an individual element in that list, which each element is a name or that particular string in cat names. And remember, because I'm trying to create a list here, brackets. Let's see what this returns. Exclamation points. Now, what if we only wanted, we can make this conditional as well. We can say B plus, let's add a question mark this time. For C in cat names, if the length of C is greater than 4. So let's see how this differs from what we previously did. One of our elements, figs, is not that long, so it didn't include it. We've modified it by creating this condition. Now, of course, you also could have done this without modifying anything, just saying C for C in cat names if length C is greater than 4. And then you would have taken all of your elements that have a length greater than 4. So that's one of the ways that you can manipulate a list. All right, let's talk a little bit more. Were you guys already familiar with the term strings that I was throwing around?
This might be a good time to use the Zoom reactions thing in the participants window of yes or no.
I see a thumbs up, that's nice.
Seeing a few yeses, yeah.
Okay, nice, but if you're not, that's perfectly okay. A string is something like, an example would be one of these. It's not necessarily always a word, but how we represent how we represent writing in our codes. It could be a single letter, it could be a word, it could be an entire paragraph. It's basically in contrast to numbers. So here, I'm going to take an example. Let's create a string. To avoid typing, I just copied. Now let's see what that looks like when we return my string. Now, strings are similar to lists in some ways and different in others. So what do we think is what are we gonna get when we run this? Any clues? Come on, suggestion.
The word in.
Oh, the word in. See,
Sorry, R.
Perfectly valid suggestion, but in your string, your elements are actually not your words, it's each individual character. So what we're gonna get is the R from there. So remember, the 0 is T, and then H is 1, E is 2, R is 3. But the word was a perfectly reasonable suggestion. Now we can also grab a section of our string by indexing it. For example, my string from 10 to 18 will return squirrel. So now let's look at how we can alter our string a little bit. We can identify that section that says squirrel. And let's change that. I'll say what did I do? Oh. Does anyone else want to chime in? I should have asked this first. I totally forgot that we can't do this. And because it's not a list. So let's fix that. Basically, the moral of this is just don't be like Dina and get nervous and forget everything. Instead, with strings, we use the replace feature. So we would say string.replace, and then we first enter the segment that we want to replace. So we identify that directly. Like in this case, we identify squirrel. Comma, spider. This is going to replace squirrel with spider. There's a spider in the tree and it looks like it's dancing. This method will not work for strings. That's what we use for this. Okay, we can also find an element, which can be, again, quite helpful. So let's locate an element. MyString.find. And let's find where tree is at. Got my quotes there. 27. So when it gives you 27, let's look at our string again. That means tree begins at the 27th element, not that it ends at the 27th. All right, let's now move on to a different topic. Let's talk about dictionaries. Can you, again, use the thumbs up feature and let me know if you guys are who's already familiar with a dictionary and who's not? Thumbs up if you are, please. Cool, okay. I'm seeing some thumbs up, that's nice. Well, anyway, a dictionary is a way to execute mapping between two values, which we would refer to as keys and values. So let's create an example dictionary. So your dictionary will be defined by braces, not brackets or parentheses. I think this is probably the first time some of you have seen braces in Python. So we start with our first element, and then with a colon, we identify what we want it to be mapped to. So I'm mapping A to 1, as in A is the first letter of the alphabet, and then I'm going to go B is mapped to 2, and then C mapped to 3. Now let's view our dictionary and see what it would look like. Can anybody make a suggestion of what they think a dictionary might be helpful to? It's different than a list. Again, remember, we're not just storing information, we're identifying two parts. So we're identifying how one part relates to another part. So let's look at one more example of how that could be used. So dictionary, this will return the value associated with A, 1. So anyone want to throw out an example of where they think a dictionary might be more helpful than a list or more convenient to use than a list?
Maybe, for example, if you have a periodic table, you can associate the elements with the atomic mass. And
Yes, that is a fantastic example, because then you could just look for your element without having to parse through something. Right, now we can also modify our dictionary quite easily. This is, again, similar to working with a list. So let's say we want to add this element, we want to add D. We want it to be 4. Then our dictionary just now includes D. Quite simple. Okay, so another a little bit of a more interesting example of how a dictionary might be used. And again, you may be seeing this in the future. If you have a function, say a recursive function. Now, a recursive function is one that works by calling itself repeatedly. It actually uses itself to make its calculations. I know that's a bit of a messy idea, so if that doesn't immediately make sense, that's all right. You aren't going to need that idea right away, but it's a good thing to keep in your mind for the future. It's worth knowing. So say you have a function that works recursively. Recursive functions are very time expensive because say you have a function that depends on its previous calculations. So if we input 1 into a function, it just works by calculating with 1. And then we input 2, and whatever we're expecting for it to give us back for 2 is dependent on its calculation for 1. So each time we call that function, it's going to have to do a lot of calculation if we do it with a higher number. But if a dictionary was being created, saving each value and mapping the input of 2 to the output of 2, the input of 3 to the output of 3, you could more easily work with that function and not have to waste so much time. Does anyone want to talk about that idea? I think that's probably the most interesting thing we've talked about so far. So if that doesn't make sense, happy to elaborate on that. Does anyone want to suggest any areas they wonder if it could be used? Okay, in that case, I guess we'll move on. So something else we can do with our dictionaries, just like in a list, we can see if an element is in a dictionary. So is A in our dictionary? And say we try that with B, we will get false. All right, now moving on to a different topic. Let's talk a little bit about lambda functions. Lambda functions are a type of sometimes temporary function that does not include a name. So let's go ahead and a lambda function can take in any number of inputs, but will only actually include one line. It will be contained to one line. Like for example, let's say x, and you would actually spell out lambda. Let's see here. I'm using x kind of to name it, but not really to name it, as a lambda function doesn't have a name. But let's look at how they're written. You start with lambda, y colon. So y is what the input is going to be. And then after the colon, we define what we wanted to do. So let's say we wanted to square a number. So we're calling this function x here by setting it equal to x, but the lambda function itself is just this bit. I'm just creating another function and calling this function the lambda function. Is anyone unclear on what I mean by that? And let's look at how that could be used. Now we can say x42, and what is that going to give us? Oh, I'm sorry. What's that going to give us?
Should return 4.
Exactly, yes, because we're just having this function work like that. This is kind of a pointless example. As you see, like I could have just defined a function x. This is just quicker. There are a lot of instances where lambda functions are going to be more useful. Like for example, you might create functions where you have embedded lambda functions, or you might have other functions that don't return a single value, they return an actual function. Does that make sense? The idea of a function returning a function? I'm interpreting silence as yes. All right, let's look at one more. So we said they're only one line, but they can take in however many values we want. So just to make sure everybody's clear, let's say lambda yz input, and our calculation is going to be y times z. So if we say x 2, 4, what will this yield?
That should return 8.
Yes, exactly, because it's just the exact same thing using two variables. All right, now let's do a slightly more interesting example here. Let's say that x equals lambda y. Oh no. No, okay, I have a better idea. Let's create a new function, and in that function, we're going to return a lambda function, because I mentioned that can be done. Now let's call this, does anyone want to throw out a name for the function? Something entertaining, preferably. Gianluca, got any ideas?
How about good morning? Good
Perfect,
day.
thank you. Sorry for calling on you.
Yeah, it's all good.
Good morning, and it is going to take in one value, which is y. And also remember, if anyone has any questions about things not directly related in this lecture, like just about defining functions in general, again, welcome to ask. You can really ask whatever you want. So all this function is going to do is return another function, which may seem pointless, but we're going to see an example of how it can actually be a bit useful. So the function it returns is going to be a lambda function. which takes in the variable x, and the necessary calculation is x to the power of y. Okay, now, what do you guys predict will be the result of this? When I push run right now, what is going to happen?
So good morning is going to pass 2 into the function that we defined, but that function returns the function x to the power of y.
Correct?
And what's curious about this is I'm not sure exactly what x is going to be in our case. I think it might just completely fail, but could be
We're not
wrong.
actually going to get an error. What we're going to get is something else. You're on the right track, but we're not going to get an error. We're going to get something else. Any ideas? It can be somebody else too, or you can keep going. So let's think about what this is. So good morning takes in y. So we've taken in y, but what are we actually returning with this? Are we returning a value? Because say, for example, we were expecting 2 variables, we didn't give it 2 variables, and then we'd get an error. But that's actually not what's happening here. What is happening?
So essentially, we're just creating the function like that would take in x to the power of 2.
Exactly, we're creating the function, so the result is going to be a function. We're not going to get an output. Now let's look at how we can use this function definition that returns a function to as a function generator to create other functions. So let's say square equals good morning. Can somebody just in regular English explain what this means? Squares equals good morning too. Like, what is squares? Now, we've defined it as good morning, which takes in this input, the y, which is 2. So what would that look like? What would its returning look like?
Squares should be the function x to the power of 2.
Exactly, yeah. That's also kind of given away in the name. So if we ran squares 3, we're going to get 9. Now we can also, based off of good morning, we can define any function that takes its input to the power of whatever we define in our definition. So cubes equals good morning 3. So this is going to cube something. Honest. Make sense? All right, so that's where we can use lambda functions. Any other questions regarding lambda functions? Anyone want to throw out an idea where they think, an example where they think lambda functions might be helpful?
I mean, this might be a bit technical, but suppose you wanted to generate a basis set of some sort of function. I could see this being useful potentially there.
Yes, good thinking. Okay, so in that case, I'm going to stop my screen share. So actually, I guess if we don't have any remaining questions, does anybody have any immediate questions about their module that they'd like to address?
Oh, the module was just released like during this
never
lecture.
mind. Okay.
I'd be very impressed if anyone had questions about the module right now.
You would have read it very quickly.
To be fair, I was going to ask where it was, but like you answered that question, so thank you.
Yeah, it's up on Recourses right now. I just saw it. Oh, maybe we could go back to external imports real quick.
Oh, yes. Okay, so what was the question on external imports?
You had just imported pandas as PD, and maybe you could show everyone how you can use that code.
Sure. Can I take an example from the module?
Yeah, sure.
Okay, thanks.
Everyone, you get a free checkpoint for showing up to this lecture. Isn't that great?
Yeah, it's pretty great. Yeah.
Mhm.
All right, so, or should I not do this? Can I bring up the example in the module? Is that okay?
Yeah, okay.
All right, so we already imported pandas as PD. I believe this is actually taken straight from your module. Let's see. Where data frame? Wait, you know what? I shouldn't have done that. Sorry. Okay, sorry for getting kind of fuzzy-headed, but we are actually about out of time, so it might be better to address this in Slack to whoever wants to talk about it later, if that's okay. All right, so if there isn't anything remaining, I'm going to go ahead and end the lecture. Does anyone have any last minute, like, quick things? Okay, well, in that case, thank you everyone for coming. As always, feel free to address any questions in Slack and we will get back to you. Okay, bye for now.